Okay, here we are, Statistics and Mechanics, Year 1, Chapter 9, Mixed Exercise. Question 2. So, particle is moving on an axis OX from its time equals 0 to time 32 seconds. Particle is traveling with a constant velocity of 15 meters. Particle then decelerates from 15 to rest in t seconds. Sketch a velocity time graph to illustrate the motion of the particle. Okay, so we have a axis like that, and we have time on the bottom, time in seconds, and we have 0 seconds, 32 seconds, 32 seconds, and then the particle then decelerates from 15 meters a second to rest in t seconds. So I guess over here we've got 32 plus t. Okay. Traveling at 15 meters a second, so we'll have 15 meters a second, and we'll have velocity. Okay, and so we just have a line come out here to 32, and then another line come from that endpoint down to here, come to rest. Okay. Part B. The total distance travelled by the particle is 570 meters. Okay, 570 meters. All right. Sketch, find the value of t. So the distance is equal to the area underneath the graph. So we can say that that distance is equal to the trapezium formula, because that's what we've got here, which would be a half a plus b times the height. Okay, where we've got the height here, and we've got distances a and b here, and so we can say that 570 is equal to a half of 32 plus 32 plus t times by 15. Okay, which will leave us with just t. All right, so what do we have then? How many halves in that? 1,140. Okay, so if we do 1,140 is equal to 15 times 64 plus t. Let's divide the 1,140 by the 15. 76. 76 is equal to 64. T minus the 64, leaving t to be 12 seconds. Okay, so that's 12 seconds up there. So 32 plus 12 brings us to 44 seconds on the original one. Sketch a displacement time graph illustrating the motion of the particle. Okay, so it starts at a point there, it does 15 meters a second, and then it comes back to there. Displacement time graph illustrating the motion of the particle. Right then. So what's going on? So it's displacement displacement, we get to 32 seconds, and then we get to 44 seconds at that point. So we know as we come up here, we will have been doing 15 meters a second for 32 seconds. So as we come along there, we end up with 32 times 15, 480 meters. There. And now what we need to know is how long it would take to slow down from 15 meters a second back down to naught in 12 seconds, and what's the distance that you cover there. So if we take a suvat of that, the distance is what we're looking for. The initial speed was 15, the final speed was 0, the acceleration I don't know, and the time was 12 seconds. So grabbing the suvat equations, okay, which are in the book and are available for you. Okay, we are going to want, which one is it? No acceleration. So s equals a half u plus v over t. So that is s equals a half u plus v times t. So s is equal to a half of 15 plus 0 times 12. And 15 times 12 is 180 divided by 2, 90. So s is equal to 90. So we do 480 meters, and then 480 plus 90 gets us to 570. Okay, so now we can do distance time here. That goes to there, 480, and then we go from there and we go up to 570 meters, something like that. Okay, should probably 480, 95. Should probably change the scales on this to make it a bit more believable in terms of if we did 1, 2, 3, 4, 5. So that's 500, 480, 570. It's going to be, let's just change the scales around here. Let's just say this one is okay. So 100, 2, 3, 4, 5. Okay, 1, 200, 400, 600. And so 480 is about here. So there's my first line. And then my second line is 570, which would be somewhere about there. Okay. So it's really just a case of scale. I should probably adjust the 32 and the 44 as well. But anyway, all right, we'll leave it at that.